So welcome guys to our another video, and this is the video for the parts of sequence. So one part of sequence is monotonic sequence. Otherwise there is many parts like bounded sequence, monotonic sequence, convergence and divergence of sequence, etc, etc. But monotonic sequence is one another and fundamental part of sequence, of knowing sequence. So if I consider, so let's begin with monotonic sequence, and my name is Sanjiban Bhowmik. A sequence AN is termed as monotonic increasing or monotonic decreasing. So there is two part of monotonic sequence is increasing and another one is decreasing. So monotonic increasing means 1, 2, 3, 4. This is going to be increased one by one. So this is monotonically increasing. And if I say 4, 3, 2 on, just reverse this number, we will get monotonically decreasing. Why? This is minus and this all are going to be 1 0 minus 1 going to the negative portion. So this is decreasing and this is increasing. For example, I am giving you another example like 3 4 5 6 and minus 3 minus 4 minus 5 minus 6. Can you say what is this? This is more increasing monotonically or decreasing monotonically? Yeah, this is increasing monotonically and this is going to be decreasing uh, monotonically. Why? Why I am saying you? Uh, let's move with I'm going to be highlighted this and this. I am going to understand you by notation. Means if I say 1 2 3 4 and let me denote these as some notation A1 A2 A3 and A4. You can see here 1 is greater than 2, 2 is greater than 3, 3 is greater than 4. Why I am giving this type of equal to sign? Let you understand. Uh, Monotonically sequence, either it can be decreasing or it can be increasing. If it is increasing continuously, I have to use this equal to sign here, because this is not strictly increasing, this is only increasing. Monotonically increasing function, there is also two part. One part is monotonically increasing and another one is strictly monotonically increasing. This is not strictly increasing, it can be equal to a1 is equal to a2 and otherwise it will be increasing. So combining this we can write it. Yeah, so if I write this using notation, what will be a n is greater than is equal to a n plus 1. N is the first one and n plus 1 will be the second one and n plus 2 will be the third one. It can be written as n plus 1 is greater than is equal to n a n plus 2. So here is the main funda of knowing this. And let's move forward with monotonically decreasing function. What is monotonically decreasing? Nothing but just see this number 4 3 2 1 or minus 3 minus 4 minus 5 minus 6. These all are going to be negative and this is going to be minus infinity. So this is monotonically decreasing. And let's move with an example like now let me understand it by notation. It is monotonically increasing, and what will be for monotonically decreasing? This is an is greater than is equal to less than is equal to an plus 1, and it will be greater than is equal to, because the first term will be the greater term or is equal to than the another, and the another term will be greater than is equal to than the another. This means 4 3 2. So let uh, do some example like to clear this confusion. Illustration 1. So the question is an is equal to 1 by 1 into 2, 1 by 2 into 3 plus 1 by 3 into 4 plus dot 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 plus 1 by n into n plus 1. So what is the answer of the sequence, and find is it monotonically increasing or decreasing? So what I have to do? First, let me write the first term 1 point, and this is 1 by 2. Second term will be 3 into 2 into 3, 1 by 6. You can see three by 6. You can see 6 is greater than 1 by. So here is my some fault. Like you can see here, if I say 2, then it will include these two part. If I say a 3, this will include this 3 part. So there is some fault of mine. So let's repair it. A2 will be 1 by 2 plus 1 by 6, and this is sort of 6, 3 plus 1, 4 by 6. And you can see this 3 by 6 is less than is equal to 4 by 6. So what will be an, and this is the another term an plus 1. So the first term is less than is equal to the second term, and that will follow the third term also. So you can see here this is an increasing function, isn't it? Increasing function, what does increasing monotonically sequence says? 1 2 3 4 5 dot dot dot. This is monotonically increasing function, and n plus 1 and so on so forth. So first term is greater than 1 is first term is less than is equal to 2, and less than is equal to 3, and less than is equal to 4. So this is an increasing function sequence. So this is also a increasing sequence, and this is not the correct way to understand this sequence is monotonically increasing, or this is a is this a monotonic sequence, or etc. So let me manipulate it in the proper mathematical way. So let begin with the proper way. An can be written as 2 minus 1, that is 1, and 1 by 1 into 2, plus 3 minus 2 by 2 into 3, plus 4 minus 3 by 3, 4, dot dot dot, and the last one will follow this. So if I write is in this way, and 1 by 1.2. So this will be 1 by 1, basically this is 1, this is 1 by 2, plus this is 1 by 2, minus this is 1 by 3, this is plus 1 by 2. So see these minus minus, these all are going to nullify. So this one will be nullified by the second term, and this term will be nullified by its previous term. So what will remain constant? 1 minus 1 by 1 plus n plus 1. This is nothing but plus 1 minus 1 plus 1, n by n plus 1. And this is the most important and fundamental step of using monotonic sequence or solving any problems according sequence or related to sequence. You have to find the difference of corresponding two terms, means an plus 1, this is, if I say this is an plus 1 and this is an, so basically you have to find their difference. If you got this as positive number, this is 1 and this is positive 1, so this is always greater than 0. You can conclude this is increasing function, because if I say this is an or first term and a1 is an plus 1, then what will be their sequence, their difference? Minus 1. This is negative, so this will be less than 0. So this is monotonically decreasing function, and this is increasing. So you have to find their difference. So their difference is n plus 1, put here n as n plus 1 and n plus 1, this one, so n plus 2, n plus 1 by n plus 2 minus plus 1. And this is always greater than 0 for all n is greater than 0, because you can put here 1 and you will get 2 into 3, isn't it? If you want to put the value of n as 2, 2 plus 1, 2 plus 2, you will get 3 into 4, that is 12, that is also greater than 0. So I or you can conclude that this sequence, this a plus a n is greater than 0. So a n plus 1 a n. So here is the thing to find value of value, not exactly value. This is uh, how we can find this is monotonic or not. And let's see their graph. If I say monotonic sequence, number 1, increasing in monotonic sequence. So basically what will be the graph is this. This is the graph of monotonically sequence. Monotonic sequence, but this is increasing. And if we take this, if we find the value of the graph of decreasing in monotonic sequence, that is that will be this is decreasing in monotonic sequence. So here is the graph of there. So can you ask, if I ask you about this graph, is the graph monotonically increasing or decreasing, or this is monotonic or not? Can you answer this? You can notice this is increasing and this is going to be decreasing, and this is also increasing, this is also decreasing. So basically this graph is not monotonic graph. So here the session ends. Thank you for seeing this video. Stay with us.